All right. So today we are talking about rotations around a point that is not the origin. Okay, so yesterday we learned our rules. It was all of our rules, 90 degrees counterclock, 180 degrees counterclock, 270 degrees counterclock. Those rules exist only around the origin.
Are we going to be writing anything up?
Yes.
Oh, so we write this down.
So I'm going to show you two different methods, and you can pick which one you want to do. It's up to y'all. So the first one I'm going to show you is called translate then rotate. So if you look in our problem, and yesterday it talked about rotating around the origin, now we've got rotate around the point C11. So we're no longer rotating around the origin, so we've got to do a little bit of maneuvering before we can really get it ready to rock and roll and do our rotation rule. So the first thing we're going to do, it's probably easier if you guys type these rules out too than writing them. So we're going to translate our point of rotation. For number one, it's 1, 1 to the origin. And then we're going to figure out whatever vector it took to do that. What's a vector?
Direction and magnitude.
A line that has both direction and magnitude, right? What's magnitude? Fancy word for distance, absolutely. So once we figure out that vector, we're going to take that vector and move every vertex in our pre-image the same vector. Why is it important that we move it the same vector?
Matching.
What do you mean it's matching?
Like the pre-image and the new image is actually like this.
Right, we don't want to change the shape of our pre-image, right? Once we moved it that vector, we're going to go ahead and rotate that rascal. Because our rules only exist where? Around the origin, right? And then once we rotate it, we've got to undo what we did in step 2. It's not that bad. Y'all ready? It's only extra steps because we don't just have a 1-1 rotation rule. Think about the infinite number of, you'd like having to write out every rule. That would stink, right? So we're gonna go ahead and graph our pre-image. Don't do it to me. We're gonna go ahead and graph our pre-image and our point of rotation. What are you talking about? So B is at 2, -1. And D is 1 at triangle.
Why is it just ABD?
Okay, so BAD is our pre-image. And then we're going to go ahead now and plot our point of rotation, which for number 1, our point of rotation is 1, 1. And that's C. Okay. So yesterday we rotated around 0, 0. Today we're rotating anywhere else. So this is our point of rotation. This triangle is going to have to turn around the point 1, 1. But our rotation rules only exist around the origin. So let's make C, let's go ahead and translate C to the origin. What vector moves C to the origin?
-1, down 1, and left 1.
So we're going to go down 1 and left 1. How would I write that as a vector? -1, -1. So that is the vector we're going to use to translate triangle BAD so we can rotate it. It's not that bad, right?
Not terrible, but
Nah, we haven't done anything.
pretty darn good.
Pretty darn good, right?
Not rotating it yet, but
Nope, so that's the vector we're going to use is -1, 1. So I'm just going to write it here so we know what we're doing. Guys, and as you go, when you look at this, what's the vector to move it always going to be?
Negative.
Well, for this one, yeah, but it's always going to be the what? Opposite of that point. For this one, it's negative, but what if it was -1, -1?
Negative one.
But what if it was -1, -1?
Times negative one, it would be positive.
Oh, you mean negate it? Oh, okay, yeah, that's good. You can negate it, yeah.
here,
It's the same word, it means the same thing. So we're going to do 90 degrees rotation on this one. Okay, it gave us both, we're only going to do one. If so they told me 90 degrees counterclockwise. What if they only told me 90 degrees? Do I assume counterclockwise or clockwise? All of our rules are always counterclockwise. If they just say a number, we're going to assume counterclockwise. They need to specifically tell us clockwise otherwise. That was tough words. All right, y'all ready? Whole squad ready? I know, it's okay. So here we go. We're going to start with vertex B. So the original location for B was what? 2, -1. So we've got to translate 2, -1 by the vector. What was our vector? -1, -1. I'm gonna draw this first step out only this time. The next time we won't do it. We'll just do it in our heads. So we're going 2 - 1 and -1 - 1. So our original vertex is now under this vector for our translation. So 2 - 1, -1 - 1. I'm listening. Go ahead.
so I'm confused why we just wrote all that out.
I'm just trying to show it. Next time we'll just do it in our head.
What if we can't? You just go to the graph and move it down.
You could just go to the graph and move it down, but then you're still going to need those vertices. So either way, I mean, you can do it with algebraically, or you can get it right off the graph. It's up to you. The graph could be easier, yeah. If that's how your brain works, and that's how your brain works. So what are the new translated coordinates for B? 2 - 1 is 1. -1 - 1 is -2. Now that we've translated it, we can go ahead and rotate that rascal. We're going to rotate it 90 degrees. What is our rule for a 90-degree counterclockwise rotation? What's our rule? Swap them. So Y and X are going to trade places, and somebody gets negated. Who gets negated? The Y or the X? The X or the Y? It's the Y.
What did I tell you?
Y gets negated.
I was on the side.
Just playing it safe. All right. So we're going to trade places. Okay. Quiet, weirdo. We're going to trade places. So -2 and 1 are going to trade places. And we're going to negate the original Y. So because my original Y was negative, it's now going to become positive. Now that we've rotated our figure, one more step, what do we got to do? We've got to untranslate it. We've got to move it back. So if we went -1, -1, how do we move it back? +1, +1. And we get that weird looking smiley face.
This is so much more.
So what is our new, what's the location of B prime? 2 + 1 is 3, 1 + 1 is 2.
Wait, there's more ways of doing this.
Like 4 different ways.
What do you mean it's 4 different ways?
Like flip-flopping numbers will allow
But there was only 3 steps, so we translated it to the origin, rotated it around the origin, and then after we rotated it, we put it back by doing the opposite vector from the beginning.
Wasn't it supposed to be -2?
So it was, so when they traded places, it was originally -2, 1, but because we negated our original y, it becomes positive.
And then why don't we add?
Because we have to undo this translation at the beginning. So we translated it to the origin because that's how our rule exists, and we've got to undo it at the end to put it back. Well, we got 2 more. Let's keep going. See if you like it. What?
You shouldn't give us more than 3 of these.
Well, you've only got 4 of them, so it's okay.
4's doable. 4 what? Problem?
All right. Did it though? Exactly. Sure. Go blow your. I have tissues. We do it in the hallway. All right. So A, our original location for A was 5, -3. What are we going to do first? We're going to translate it by our vector. What was our vector? -1, -1. Which puts A where? 5 minus 1 is 4. -3 minus 1, -4. Now that we've translated it to the origin, we can apply our rotation rule. Negative yx, because we're rotating it 90 degrees counterclockwise. So we're going to trade places, -4, 4, and we're going to negate our original y. So our original y was negative. So now it becomes what? Positive.
I think we should make the homework even.
Okay. Now that we've rotated around the origin, we just do what? We got to reverse our translation. Yep. So we rotate it back.
Why do we gotta reverse it?
Because our first step was we moved it to rotate it, so we got to move it back. Yeah. So we can't move it and then just leave it there because now we're going to be a little cattywampus. We want every point to be the same direction, the same distance. It's a good word. Okay, so A prime is 4 plus 1 is 5. 5 plus 1, or 4 plus 1 is 5. So A prime is 5, 5. Uno más?
There's got to be a simpler way to do this.
And our last vertice is D.
I always teach the hardest one. The hardest one first. Can we do it on?
Yeah, we'll practice it on. Y'all practice on the next page on your own.
If
Yeah.
you're minded taking the ones and then readding them back,
Uh huh.
and you just remove both steps.
No. Because then so if you remove both steps, you're rotating this point around the origin. Like your original vertex, you're rotating around the origin. So you're not rotating around 1, 1. So if I just try to rotate 5, 3, it becomes 3, 5. What do we end up with? Yeah. So you can't. So you've got to move it to the origin so you can get your rule and then move it back. Yep. Okay. So we've got D. So we're going to translate it to the origin first with the vector -1, -1.
0, E, 8.
So 1 minus 1 is 0. -4 minus 1 is -5. Now we need to rotate it. What's our rotation rule is -yx. So we're going to trade places. So now -5 and 0 swap. Our original y was negative, so when we negate it, it becomes positive. And now, hey guys, listen up. Now we're going to translate back 1, 1.
Do any of these have 4 points?
Sure.
Ah.
So D prime's resting place is 6, 1.
Wait, we've already done all of that. I'm still on B.
I think that was enough to know.
Okay, so now let's go ahead and, guys, let's go ahead and graph our image. So B is at 3, 2.
B is 3, 2.
So there's B prime.
B prime.
A is 5, 5.
A is 5, 5. A prime. And D is 6, 1. D prime.
Okay, and then D is what, 6, 1? Thank you, brother.
D prime.
Okay, and then there's our bad triangle. Just flip. All right. So that's our first, that's the first way we can do it. Hey. All right, so that's our translate then rotate rule. I have a second option for you. I don't think so. I think it's about the same. So let's look at number 2. And this one we're going to rotate at 270. For number 2, we're going to use the method, what's wrong? Oh. We're going to use the method draw a new XY axis. So don't write it, go ahead and type it in there, weirdos. Okay, so the XY method is instead of moving our figure to the origin, we're just going to move the origin to the point of rotation. Yes, sir.
We have to write that down if we know we're going to use the first one.
Yeah, go ahead. You don't know that you'll use the first one. Maybe you'll like the second one better. Hey, stop. All right. So we're going to draw a new XY axis where the point of rotation becomes my new origin. So draw a new XY axis where the point of rotation becomes my new origin. Because I changed the origin, I now have to change the vertices of my pre-image. So they're technically going to be at a different spot because my origin has changed. Once we change our vertices, we can go ahead and rotate that pre-image, and then we're going to graph our image off of our new XY. That's where people get tripped up the most, is when they go to graph, they go back to the original origin, and it won't work. We need to graph our image based on the new XY axis. Generally speaking, students like this method more. We'll see what happens. We'll see what y'all think.
I love the last one. Once we understand it, looks.
The last one for me is the way I do it, because I just do it in my head and then roll with it. All right, so we're going to go ahead and graph our pre-image and our point of rotation. So quadrilateral square. We've got 1, 4. Go back to it. Calm down, hooligans. All right. So Q is at 3, 2. Hey, I don't need your commentary there, guy. That guy. Okay. U is at 6, 5. So we go right 6, up 5. Come on. And then A is right 4, up 7. So we'll go ahead and draw this rectangle looking thing. It might be a rectangle. We don't know. Eventually, we're going to learn how to prove that it's a rectangle by showing that opposite sides are congruent and parallel. Yep. It is proof. It's awesome.
We going to Sharp Top?
I don't know that answer. All right, so our point of rotation is 0, 1. So that's my C, because if they did that, it wouldn't be rotations around a fixed point. It'd just be rotation. Well, technically. So on C, we're going to draw a new XY axis. So this old one's gone. We're going to draw a new axis where this now becomes 0, 0. So we're just going to draw a brand new graph. So we're just going to go straight line. Straight line. Boom. Now the red, my new y-axis.
Oh, this is definitely gonna be better.
Okay. So the red is my new XY axis. But so because we moved our 0, 0, we now have changed each 4 of our vertex locations. So we've just got to document the new location of each vertex. What's wrong? So S, according to our new axis, where's S?
1, 3.
Over 1, up 3. Good. Our new axis. According to our new axis, where's Q?
3, 1.
Right 3, up 1. According to our new axis, where is U?
Over 6, up 4.
Right 6, up 4. And according to our new axis, is A.
Over 4, up 6.
Right 4, up 6. So in case you're wondering, so this is where we're starting, right? So we're going to go 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Now that we have our new vertices, let's go ahead and translate those. So we're going to translate 270 degrees counterclockwise. If they didn't tell me counterclockwise, how would I know it's counterclockwise? We assume every rotation is counterclockwise because that's a positive rotation on the unit circle. What's our rule for 270 counterclockwise?
Flip them, make the X negative.
Swap them and negate X. Perfect. Swap them and negate X. So we go to S prime. 1 and 3 trade places. Because 1 was initially positive, when I negate it, it becomes negative. Q prime, 3 and 1 switch places. Because 3 was initially positive, when I negate it, it becomes negative. What's wrong, dude?
It just went away and it's not popping up with candy.
Oh, I'm sorry. U, when we're going to swip them, that's a good word, Sean. We're going to swap them because my 6 was originally positive. When I negate it, it becomes negative. And the last one is A prime. We're going to switch them because 4 was initially positive. When I negate it, it becomes negative. So this is where you guys will trip up. We're going to graph the vertices of our image off the red XY, not off the original black XY. So off the red XY, we're going to plot these 4 points. And then we're done. So we're going to go right 3 and down 1. That gives us our S prime. Q is right 1, down 3. Remember, it's from the red, not from the black. So it's right 1, down 3. U is right 4, down 6. Right 4, down 6. Does that look right? All right, and then A prime is right 6 and down 4. Go ahead and connect our vertices. And we've rotated it around the point 0, 0, or 0, 1, sorry. I got you. So you've got two options. You've got translate, then rotate. You've got draw a new XY. All right, I want you guys to do the next one on your own. Once you got it right, you can go ahead and start the homework. I can zoom out.